Hello. Today we're going to be looking at annuities, and annuities are just reducing balance loans. They're exactly the same thing, but in this case, instead of showing how much is owing on the loan, it's going to represent how much money is left in an investment. And this is why I've written superannuation, like annuities, superannuation. All right, so it's going to show you get a lump sum of money, and if you're going to take that money out over time, how much is going to be left. So this is how we model it. It's exactly the same as the reducing balance loan, where the V0 is the principal, the initial value, and then we've got the next term is the rate times the previous minus the payment that you're taking out, or the payment received in this case. So here's an example of what we're going to be doing today. Reza plans to travel overseas for 6 months. He invests $12,000 in annuity that earns interest at the rate of 6% per annum, providing him with a monthly income of $2,035 per month for 6 months. Model this annuity using a recurrence relation of this form. Remember, we've got the principal, next term, rate, previous term, minus the payment received. All right, where VN is the value of the annuity after N payments have been received. So whether it's first, second, third, fourth payment, etc. So what we're going to do here, the first thing we need to do is make sure we know what V0 is. He's invested $12,000, so that's the initial amount. The second thing we need to do is get the interest rate correct. Because it's done monthly, that 6% has to be split up over the months, and there's 12 months in a year, so this is where they go 6% divided by 12, which is 0.5%. Remember, that's not the decimal yet. We've got to divide that by 100, which is going to give us 0.005. And this is where we get this rule. As we know, it's 1 at the start to retain the 12,000 plus the 0.005, that's the interest accrued. Next thing we're going to do is determine the value of D, that's the payment you're going to get. So how do we get this payment? Well, it's just in the question in this case, providing him with a monthly income of $2,035. So you don't have to overthink this. It already states in the question what you need. So you want $2,035. So our recurrence relation just reads initial value, the principal is 12,000. The Vn plus 1 equals 1.005 because we have to split the 6% over 12 months. Vn, take the $2,035 that we want to receive every single month for 6 months. Even though we only get it for 6 months, we still need to divide that interest rate by 12 because it is monthly. So once we have the recurrence relation, we can determine different things about the loan. So let's have a look at this. Use your calculator to determine recursively the value of the annuity after Reza has received 3 payments from there. So let's have a go at this. On your calculator page, 12,000. Hang on a sec, I've gone one too many there. So 12,000, enter that. And remember, we're going to multiply that answer by 1.005, and then we're going to subtract out our payment that we're going to get each single month. So there's our first value, there's our second, there's our third. And so that's part A there, and we've got the first 3 payments, all right? Which then gets us to part B. Is the annuity fully paid out after 6 monthly payments have been made? If not, how much would the last payment have to be to ensure that the annuity terminates after 6 months? So 3, 4, 5, 6, and we've got 88 cents remaining, don't we? Doesn't round to 89 because it's only a 3 in the third decimal place. So we're going to do the $2,035 plus the 88 cents gives us the final payment's going to be $2,035.88. Pretty straightforward. Then we get into the tables, all right, for these annuities. And this is where a few people still get confused about how these tables work. This table just replicates what's been happening on this calculator. So for instance, interest earned, that $12,000 there, the way they got that, they got the $12,000, and then how they got $60 for the interest earned, they multiplied it by the 0.005, which is the $60, which makes sense, doesn't it? So then we've got the principal reduction, new balance of the loan, and it's what we learnt in our previous chapters. If you're still a little bit confused, obviously this $50.13, it's 10,025 times 0.005 is going to give us this amount, and this is where the reducing balance happens. You're getting less interest in this case. And if you want to look in your textbook, this goes through how those values are made, and also if you look at my previous videos, it'll say the same thing. How to use a finance solver to analyse an annuity. Remember, this is just like a reducing balance loan, so we can use a finance solver. The same rules apply. If the bank gives you money, it's a positive. If you pay the bank money, if you invest, it's a negative. All right. The annuity, the future value in this case can only be positive or zero, because you can only have some money or there's no money left in it. Or your super's gone or all your investment's gone. Let's have a look at this question here. Joe invests $200,000 into annuity, paying 5% compound interest per annum, compounding monthly. If he wishes to be paid monthly payments for 10 years, how much will he receive each month? So, I'm going to take you straight down here. Finance solver. Remember to find that. Menu, finance, finance solver. And he's investing $200,000, so this is why it's a negative. That's his money in there, all right? It was 5% interest for the loan. I'm just going to put in the stuff that's very, very evident to find out. The future value you want to be zero because you want to find out how much money you can get per payment. And if it's going to be monthly, it's going to be 12s here. And the reason that it's 120 up here is because he wants it for 10 years. So 12 times 10 is 120, which then allows us to go to the payment, press enter, and you'll notice here it's a positive because he's getting that money back. It's $2,121.31. So that's how A works. Now, if we go to B, if he receives a regular monthly payment of $3,000, how long will the annuity last? Give your answer correct to the nearest month. This is where it gets pretty straightforward. I'm going to put 3,000 where payment is. So I'm just going to click on this, delete that. 3,000, go up to N because we want to see how long it's going to last. It's going to last 78.26 months, which they've also got there. All right, so it's going to last 78 months. It's not going to last 79 in this case, only 78 because it's not 79 yet. And in part C, what interest rate correct to the one decimal place would allow Joe to withdraw $2,500 each month for 10 years? So this time I'm going to find the interest rate. So it's a good question, this, because it's showing you how to do all these different parts. So if we want it to last 10 years, we know that's 120 in N, don't we? So 120 in N. We don't know what the interest rate is yet, but we know we want to get 2,500. So we want to negotiate with the bank how much interest rates, or what the interest rate we want it to be. All right, so we go enter. So it's going to require 8.69% to get that amount, which then leads us into the questions. Recurrence relation, I want you to have a go at those two. I've done a few here for you though. So this is question 3. Helen invests $40,000 in annuity paying interest at the rate of 6% per annum, compounding quarterly. You'll notice here I've got the 6% divided by 4 quarters in a year, gives you 1.5%. Remember, you have to divide that into a decimal, so that becomes 0.015. We'll just move the decimal place 2 spots. So that's the decimal version of that interest. She receives a payment of $10,380 each quarter for 1 year. Let VM be the balance of the loan after end payments have been received. So A, model it in this form. So V0, which is the principal, 40,000. It's already written here for us. VM plus 1 equals 1, remember 1 at the front of it, 0.015. That's the interest rate we got. VN minus the payment she's going to receive, $10,380. Use a recurrence relation to determine the balance of the annuity after 6 months. Give your answer to the nearest cent. I've said do it on the CAS. So if you do on the CAS, we've got our 40,000. Enter. And remember, we're going to multiply that by 1.015. And I'm going to subtract the payment, 10,380. There's 1, there's 2. So what was that, sorry? After 6 months. Oh, sorry. Yeah, so that's our amount right there, sorry. I've got that spot on because 2 quarters is going to be 6 months. Just had a little mind slip there. Let's go down to question 4. So we've got this table, and It actually gives you a lot of the answers already for this one. A university student is giving a living allowance of $6,000 for her first year of study. She invests the money in annuity paying an interest rate of 3% per annum, compounding monthly. From this annuity, she receives a monthly payment of $508. That's where the payments are down here. The table for this annuity is shown below. So what we have to do first of all is we have to split up that 3% per annum into months. So 3% divided by 12 is 0.25%. Divide that by 100 gives you 0.0025. Question, that's part A, the monthly interest rate. Part B, the interest earned when payment 1 is received. So it's already just told you that, it's given you the answer. So payment 1 received, interest $15, it's just right there. Part C, the principal reduction when payment 3 is received. So here's payment 3, principal reduction, just look at the table, $495.47. Part D, the balance of the annuity after payment 5 has been received. So here's payment 5, the balance is just that amount. Bingo. And then we get into some work that you have to do, the values of A, B and C. So A, to work out interest earned, I'll just go back up again. So interest earned is going to be from this balance, all right? And we're going to multiply it by the interest because we want to earn that interest. And it ends up being $8.81, which fits in along with that reducing amount. And then we've got part B, which is the principal reduction. So the principal reduction, remember, we've got the 508 minus the $8.81 that we just worked out, which goes in here, which is $499.19. And part C, which is the balance of the annuity, which is our previous balance minus that principal reduction, which gives us $3,023.45. All goes in there. Part F, the value of the last payment if the balance of the annuity is to be 0 after the 12th payment is received. They've already given you this one as well. So the 12th payment, there was still $1.97 left. So the $508 plus the $1.97 gives us a total of $509.97. Part G, the total return from the annuity. So the total return was the 12 times the $508 payments because there was 12 payments of that amount, plus the little bit left over at the end. So it was $6,097 plus the 97.97. So the total amount of interest earned over that time was the $6,097.97 minus the $6,000 they invested, which gave you a total interest of $97.97. Good luck with the rest.